Word problems involving right-angled trigonometry. Our learning goal today is to solve word problems using trig ratios of right triangles. Please ensure you have the lesson printout so you can follow along with this video. Solving triangles. To solve a triangle means to find all the angles and side lengths. We can use any combination of trigonometry and Pythagorean theorem, that's a squared plus b squared is equal to c squared, and angle properties of triangles, where the sum of internal angles of a triangle is 180 degrees. Remember, when using right-angled trigonometry, always label triangles first, opposite, adjacent, and hypotenuse. Figure out which ratio you need to be using, SOHCAHTOA, and solve for the unknown angle or side. Let's try it out. Let's solve each triangle. We're going to round the measure of each angle to the nearest degree, so the nearest whole degree, and round the length of each side to the nearest unit, so the nearest whole unit. So let's try this one over here. Solve triangle ABC. Let's first start by labeling the sides of our triangle from our angle that we know. Okay, so we're going to do everything relative to this angle for now. Okay, so let's label all the sides. So we know opposites, the 90 degrees is the hypotenuse, so this is our hypotenuse. Opposite side of this angle is side B over here, so this is our opposite. And the side that's touching our angle, that's our adjacent. So you'll notice here that we're missing both side length B and side length A. And we use trigonometry to solve for either one of them. And once we solve for one, we can just use Pythagorean theorem to solve for the other. So it's up to you to choose which side you want to choose, and you have to use the appropriate trigonometric ratios to find it. In this case, I'm going to choose side B to solve for. So we're going to use the hypotenuse and side B, the opposite, to solve for it. So let's think of SOHCAHTOA. SOHCAHTOA. Okay, so since we're dealing with opposite and hypotenuse, we're going to use sine. So that means the sine of this angle, 37 degrees, is going to be equal to opposite over hypotenuse. So our B value, we don't know what it is, over hypotenuse, which is 18. And now we can solve for what this is. We can simplify what sine 37 is using a calculator. Let's do it. So let's clear this. Sine 37 is equal to 0.601. So we can rewrite sine 37 as 0.601, and we know it's equal to B over 18, opposite over hypotenuse. And what we can do to solve for B is multiply both sides by 18. This is going to cancel 18 here, so we're going to have 18 times 0.0601 equaling B. So let's do that. 18 times 0.601 is equal to 10.83. And since the question says round to the nearest whole unit, we can look at this value here. We could use 0.8, so that's the closest whole unit is going to be 11. So we know B is equal to 11. So we can say side B here is 11. So now we know two sides of a right triangle. To find the third side, we could use Pythagorean theorem. So let's do that. Okay, let's solve for side A. Okay, and we're going to use Pythagorean theorem, which is a squared plus b squared is equal to c squared. C squared always represents the hypotenuse squared. Okay, where A and B could be these two side lengths here that are not the hypotenuse. So let's solve for what c squared is. To make things easier before we start plugging things in, let's rearrange things. Here we're looking for one of the side lengths, and it kind of matches up with our diagram. So let's look for a squared. To do that, we're going to move the b squared to the other side. So we're going to move this over here. Let's rewrite that. So it's going to be c squared minus b squared, because we moved it over, is equal to a squared. Now let's start plugging in our values. Remember, we said c squared is our hypotenuse. So we know c is 18 squared. And we know our b side is 11. So minus 11 squared is equal to a squared. And let's start solving this. 18 squared is 324 minus 11 squared, which is 121. This is equal to a squared. So 324 minus 121 is 203. So a squared is 203. To get a by itself, we just have to square root both sides. Let's square root both sides. This is going to get a by itself, and the square root of 203 is 14.24. And if we're going to round our side to the nearest whole degree, we'll just look at this number here. Since it's less than 5, we're just going to stay at 14. A is equal to 14. So we can label our a value here. A is equal to 14 centimeters. And remember, let's remember to put all the units here. So this is also 14 centimeters. So the last thing that we need to solve, to completely solve this triangle, is this angle here, theta. Now, we can use the properties of a triangle, the angles of a triangle, to solve for theta. We know that a triangle has to add up to 180 degrees, all the angles inside. We know C here is a right angle, so that's 90 degrees. We know B here is 37 degrees. So we just have to find what theta is. Okay, let's use a different color here. So we're going to do solve for theta, which is also known as angle A here. Okay, I'll just put that in brackets. So let's solve for theta. Okay, so we know altogether all three angles has to be equal 180 degrees. So we know 180 degrees is equal to 37 degrees plus 90 degrees plus our angle theta. So we can just solve these two and then move it over to the other side and solve for what that is. So 37 plus 90 is 127 degrees plus theta, we know, is equal to 180 degrees. And all we have to do is move this over to the other side to solve for theta. 180 degrees is equal to, 180 degrees minus 127, because we moved it over to the other side, is equal to theta. And we're just going to subtract these two. Theta is equal to 53 degrees. Okay, so this angle here has to equal 53 degrees. And there we are. We solved the triangle. We know all the side lengths, and we know all the angles. So sometimes it's helpful just to list all of them. We know side A is equal to 14 centimeters. Side B is 11 centimeters. Side C, the hypotenuse, is 18 centimeters. Angle A, we calculated. That's the big A, also known as theta in this case. So this little symbol here, so I'll put angle A. This symbol here that looks like a zero with a line through it, it's called theta, is equal to 53 degrees. Angle B, this angle here is 37 degrees. And angle C is equal to 90 degrees. So that is our completed solution for this triangle. Let's try another example. Here we have another right triangle, and we can see here we have one side and two sides, but we're missing the hypotenuse, this side here. We don't know what it is. We can solve for it. Since we know two sides, we can just use Pythagorean theorem. Okay, so we know a squared plus b squared is equal to c squared, and remember this means the hypotenuse squared. So we can fill in our other sides here that are not the hypotenuse. 8 squared plus 5 squared is equal to c squared. 8 squared is 64. 5 squared is 25 is equal to c squared. 64 plus 25 is 89. So c squared is equal to 89. But we want to find c by itself, the hypotenuse, so we're going to square root both sides. So the square root of 89 is 9.43. So that's equal to C. And since we're rounding to the nearest whole value, we're just going to look at this value here. If it's over 5, we're going to move it up. If it's lower than 5, we're going to keep it where it is. Since it's lower than 5, we're going to keep it at 9. So our hypotenuse is equal to 9. Okay, so we know this is equal to 9 millimeters. Now the next thing we can do is solve for one of the angles. You can choose whichever angle you want to solve for using appropriate trigonometric ratios. In this case, I'm going to choose angle C down here to solve for. Okay, so to solve for angle C, we're just going to use the ratio between a couple of the sides that are given in this triangle. And I like to use the sides that are given here, just in case I screwed up something with calculating this. The mistake that I made here doesn't have to carry on. So let's use the sides that are given, or try to use the sides that are given. So we have 8 millimeters and 5 millimeters. Okay, so let's label all the sides now. From angle C, we're looking at the opposite. So this is our opposite. And we know the one that's touching it, that's not the hypotenuse, is the adjacent. So this is the adjacent. So we have opposite and adjacent here. So what we can do is start with SOHCAHTOA. So we're going to think of SOHCAHTOA and see which ones we're dealing with. Since we have opposite and adjacent, we're going to be dealing with tan. So we know the tan of angle C is equal to opposite over adjacent, which is, from this angle, is 8 over 5. Okay, so tan C is equal to 8 divided by 5, which is 1.6. Okay, and now to get the angle C, we just have to do the inverse of both sides, so we can get angle C. So we can take the inverse of this, so let me rewrite it. So tan inverse of tan C. So again, we have to take it on both sides, 1.6. The tan inverse is going to cancel the tan, and so C is equal to the tan inverse of 1.6. So let's just plug that into our calculator and figure out what that is. So we have second function, tan inverse of 1.6. Let's close our bracket. We're going to get 57.99, and rounding that up to the nearest degree is 58 degrees. So we know angle C is equal to 58 degrees. Okay, so we know angle C, 58 degrees. So the last thing that we're missing is angle A. And let's use a different color to solve for this. Is green. So we're looking for angle A. And to find angle A, since we know 2 of the angles, remember this is 90 degrees, we know 2 of the angles, we can solve for the third angle using the properties of a triangle. Remember, all angles have to equal 180. So we're solving for angle A, which is going to be 180 degrees is equal to 90 degrees plus 58 degrees plus angle A. So we can add these two together. 58 plus 90, that's 148 degrees, equal to 180 plus A. And then all we have to do is move that over to the other side to solve for A. 180 minus 148 is equal to A. A is equal to 32 degrees. Okay, and then we can just label everything here, just list them all. Here. Before we do that, let's just fill this in. This is 32 degrees. Okay, so we solved this triangle. So let's just list all our angles and sides. So we can see side B, which is the opposite of angle B, is 9 millimeters. So we know side B is equal to 9 millimeters. We know side C opposite of angle C is 8 millimeters. And side A, which is opposite of angle A, which is 5 millimeters. Now let's list our angles. So angle B, which is this one in the corner here, is going to be 90 degrees. Angle C, which is this corner here, is going to be equal to 58 degrees. and angle A, which is in this corner here, is equal to 32 degrees. So that is our solution to this triangle. Let's try one more example. So let's try our last example here, triangle QRS. So where you begin to solve these things is up to you. You can start with the trigonometric part, or you can start with solving the angles. So it's going to be your choice. For me, for this one, I'm going to start by solving for angle Q, this angle over here. Since it's the one angle that we don't know, we can use the properties of a triangle to solve for it. So let's solve for Q. So for angle Q, remember we're using the big Q for the angles and the lowercase letters for the sides that are opposite those angles. Okay, so let's solve for big Q here, the angle. We know altogether 180 degrees for a triangle is equal to R, which is 90 degrees, plus S, which is 42 degrees, plus Q, and that's the only one we don't know. So 90 plus 42, that's 132 degrees, plus Q, we know is equal to 180, and we just move this over here to the other side. So 180 minus 132 is equal to Q. 180 minus 32 is 48. So Q is equal to 48 degrees. So we know this angle is 48 degrees. So now let's solve for side Q. And so side Q is the side opposite of the angle Q. So it's going to be here. Why don't we label all of them while we're here? So opposite angle R is lowercase r, which is our hypotenuse in this case, the longest side, and then we'll have side S over here. Okay, so let's solve for side Q. Okay, and so let's use the angle that we're given here just to minimize any errors carrying through, just in case I calculated something wrong. So we're going to use angle 42, and we're going to use this side here, because it's the only side that we know, which is 13 kilometers. So side S is 13, and we're looking for this side here. We don't know what it is. So this is going to be, if we're looking at this angle, this is going to be our opposite side, and this is going to be our adjacent side, the side that's touching the angle, but is not the hypotenuse. Okay, so here we have the opposite and we have the adjacent. Okay, so now we could think of SOHCAHTOA once we have everything labeled. SOHCAHTOA. And we just have to see what we're dealing with, opposite and adjacent. So that's going to be tan. So we're going to use this one. So let's fill this in. We know tan of 42 degrees is equal to opposite over adjacent, which is equal to opposite, which we said was 13 from this angle, and adjacent is Q, we don't know what it is, and we're going to be able to solve for that. So we have tan 42 degrees is equal to 13 over Q. So we can figure out what tan 42 degrees is by plugging that into our calculator. So tan 42 degrees is equal to 0.90. Okay, so we're going to get tan is equal to 0.90 is equal to 13 over Q. Now we just need to figure out what Q is. And to do that, we're just going to multiply Q on both sides to cancel the Q on this side. So we'll have Q times 0.90 is equal to 13. And to solve for Q, we're just going to divide 0.9 on both sides. So these are going to cancel. We'll be left with Q is equal to 13 over 0.9. Okay, so let's just plug that into our calculator and figure what that is. So 13 divided by 0.9 is equal to 14.44. So our Q here is equal to 14.44, and we'll just round that to 14, and that's kilometers. So we know Q here is equal to 14 kilometers. Okay, so the last thing that we need to do is solve for r, and then we could use Pythagorean to do that. So let's go ahead and do that. Side r, our hypotenuse. So we know we can use Pythagorean. We know a squared plus b squared is equal to c squared, and this is our hypotenuse. So we know the two other sides. We have 13 squared and 14 squared, the side we solved for, and we're looking for c squared. So 13 squared is 169. You just plug that into a calculator. And 14 squared is 196. Again, you can just plug these into a calculator to find them, is equal to c squared. 169 plus 196 is equal to 365. So this is 365 is equal to c squared. Now we want to find c by itself, so we need to get rid of the square. So we're going to take the square root of both sides. And the square root of 365, I've done it here already, I'll just do it again for you. So square root of 365 is equal to 19.1. So c is equal to 19.1. Or if we round that to the nearest, is 19. So we know c, and this is our hypotenuse, so let's not get confused with these letters that are everywhere. So this is 19 kilometers. Okay, and now we can just list all our sides and angles over here. So we'll do QRS, so these are our sides. So side Q, we said was 14 kilometers. Side R is 19 kilometers. And side S is equal to 13 kilometers. And now we have our angles. So angle Q is 48 degrees. Angle R, 90 degrees. And angle S, which was given, is equal to 42 degrees. Okay, so that is our solutions for our triangle here. So let's move on to word problems. So when we're dealing with word problems and right angle trigonometry, we're usually dealing with angles of elevation and angles of depression. Elevation usually means up. So this is an angle of elevation. And to know it's an angle of elevation, we look at our horizontal line here, and then we see which way our angle from horizontal is moving. Here we can see it's moving up. So that's angle of elevation. The angle of depression usually means down, like you're looking down. So this is an angle of depression here, and the way we tell is you look at the horizontal line, and then we look at which way the other line is moving. So in this case, it's moving down. Okay, so let's take a look at a couple of examples here. So the angle of elevation here, you can see we have our horizontal line right over here, and we can see it's going up from the horizontal. So our angle of elevation is 36 degrees, 36.03 degrees. And here the angle of depression is shown as 54.14 degrees. So our horizontal is here, and our depression is here. So let's practice and let's state whether each angle is an angle of depression or an angle of elevation. Okay, we'll write E for elevation and D for depression. So number one, we can see that the angles, the horizontal is over here, and from the horizontal we're going down. So this is the angle of depression. Number two, what do you think this is? So here's our horizontal, and our vertical from this point is going up. So this is elevation. Number three, what do you think? That's right, depression. And angle four, really good, that's elevation. Wow, you guys are getting good at this. Okay, let's draw an example of angle of elevation. So if our horizontal line is this way and we're looking to, let's say, the left, an angle of elevation could be this way. Right? And let's draw an angle of depression. Here's our horizontal line, and let's say we are looking right. So then if we're looking down, the angle is going to be this way. So this is going to be our angle of depression. So we're going to be using this idea to solve different types of word problems. So let's begin. In the real world, trigonometry is used to solve for the height of very tall buildings or mountains, or the distance of a very far away object. Surveyors use a measuring instrument called a transit to help them find angles of depression or elevation. You may have seen people outside using these devices before. Let me show you what it looks like. So you may have seen people near or on a construction site looking through this tripod looking thing. And this is not a camera. This is what we call a transit or a clinometer. And it's a device that is used to measure angles so they can calculate the heights and distances of different surfaces or objects. Okay, and you can see here a surveyor makes approximately $63,000 a year, $30 an hour, and all you need is a bachelor's degree. So just graduate university without doing any specialty, and you can be making this money. It's pretty good money. So let's get back to the math. Example 1. A surveyor is standing on a cliff that is 80 meters high. He's using a transit that is 1.5 meters high. The surveyor sees a parked car at the bottom of the cliff. The angle of depression to the car is 34 degrees. How far away is the car from the base of the cliff? So a hint to these kind of questions is always draw a picture. So let's begin. So let's first start by drawing our diagram here. So we know there's a cliff and it's 80 meters tall. Okay, so 80 meters tall. He's using a transit that's 1.5 meters tall. So there's a guy at the top, at the edge of the cliff here, using a transit, that device that we saw, and it's 1.5 meters tall. Okay, and this will be the ground over here. So from the base of the mountain to the top of the transit, we know is a total of 81.5 meters. Okay, and he's looking at a car that's parked at the bottom of the cliff. This is a car down here, and it's parked at the bottom of the cliff, and he's looking down, so looking across this way, and he's looking down this way at the car, and he sees that it's an angle of 34 degrees to the bottom to get to the car. Okay, so we want to know how far away from the base of the cliff is this car. So some things that we can realize here is that if we draw a line straight across, the distance between here and here is also 81.5 meters. Okay, and we can start answering this. So we're looking for this distance here, which is the same as the distance from the cliff bottom to the car. Okay, so really we're just looking for this distance over here, x. We have this side over here, and we know the angle here, and this makes a 90 degree over here. So it's just a right triangle. So from this angle, what do we know? We know this side, which is opposites. This is the hypotenuse. We don't really need to solve for this, but we know it is the hypotenuse, and we're looking for x, which is the adjacent. Okay, so since we're dealing with opposite and adjacent, we could use, or we can think of SOHCAHTOA before we select anything. So, SOHCAHTOA. So we're looking at opposite and adjacent. So we're looking at TOA, tan. So we can say the tan of 34 degrees is equal to opposite over adjacent. So opposite is 81.5 degrees over adjacent, which is, we'll say, is x, and this is the same distance over here. So what we need to do is just solve for x, and we can do that. Let's first figure out what tan 34 is by plugging it into our calculator. Clear that. So tan 34, is equal to 0.6745. So this is equal to 0.6745 is equal to 8.1 or 81.5 over x. Now to solve for x, we can multiply x on both sides, and that's going to cancel x over here. So we're going to get x times 0.6745 is equal to 81.5. Now to solve for x, we just have to divide out both sides by this decimal to cancel it on this side. And let's divide it out here, 7.45. So it's going to cancel it here, and we're going to get x is equal to 81.5 over 0.6745. And let's just plug that into our calculator to figure out what x is. Okay, so we have 81.5 divided by 0.6745, and we're going to get 120.83. So x is equal to 120.83. So that's this distance over here, 120.83. And it's the same as up here, 120.83. So we can conclude, therefore, the car is 120.83 meters from the base of the cliff. Example 2. From a point 10 meters from a building, a surveyor measures the angle of elevation to the top of the building to be 65 degrees. She's using a 1.5 meter tall transit. How tall is the building? Okay, so let's draw our diagram here to get started. So we have some building here. We'll draw the edge here. We have a person standing down here 10 meters away, and they're using a transit that's 1.5 meters off the ground. Okay, so we know this is 1.5, and from the transit, they're looking up, and we know this angle here going across is 65 degrees. This is the angle of elevation, pointing to the top of the building here. Okay, and we know the distance between here and here is 10 meters, as I said, 10 meters from the building. So this distance here is also 10. So what we want to do is calculate the height of the building. And now two things you have to be aware of is that we have to calculate the height from here to here, but then we're going to have to add at the end the 1.5 from where the transit begins, because we're not measuring from the ground in this instance. So let's get started with what we know. Okay, so we can see that it's a right angle, and the first thing we can do is just label all our sides. So we know that this is from this angle here, since this side is touching it, this is going to be our adjacent. The side opposite the 90 degrees. This side here, the longest side, is the hypotenuse. And this side here that we want to find the distance for, this is the opposite. So it's opposite this angle here. So this is the opposite. Okay, and so we're dealing with, we want to find what the opposite is, and we have the adjacent here. Okay, and we know that the angle of elevation is 65 degrees. So we're dealing with opposite and adjacent. So let's go through our SOHCAHTOA and see which one we're going to use. We have SOHCAHTOA. Okay, and so we're looking at opposite and adjacent. So that's going to be tan. So we can do the tan of this angle here. So tan 65 degrees is equal to opposite over adjacent. So opposite is the side that we want. And we know the adjacent is 10 meters. And we can solve for what tan 65 is in our calculator. So let's do that. Let's clear this. So tan 65 is equal to 2.144. Okay, so this is 2.14. We'll leave it at that. And we'll have opposites over adjacent here, and we just want to figure out what our opposite is, so we can multiply both sides by 10 to get rid of the 10 on the bottom here. So these are going to cancel, and we're going to get 10 times 2.14, and since we have it in our calculator here, we just multiply by 10, which is 21.44. So 21.44, we'll leave it at 21.4. Sometimes it'll specify how many decimal places. For now, we'll just leave it to one decimal place. Okay, so it's 21.4 meters tall. So that's this distance from here to here, 21.4. So So there's one extra step we have to do here, because since we're reading from 1.5 meters off the ground, we have to add that 1.5 to get the total distance here. So we have 21.4 plus 1.5 is equal to our total height of the building. Okay, and 21.4 plus 1.5 is 22.9. So our total height of the building is 22.9 meters. And that'll be our solution. Example 3. Taeyeon and Yuri live in apartment buildings that are 30 meters apart, as shown. So we can see the distance between the two apartment buildings where they live are 30 meters apart. The angle of depression from Taeyeon's balcony to where Yuri's building meets the ground is 40 degrees. So looking down from Taeyeon's balcony, it hits the ground at an angle of 40 degrees. And the angle of elevation from Taeyeon's balcony to Yuri's balcony is 20 degrees. So looking up from this angle from the balcony is 20 degrees to Yuri's balcony. So question A asks, how high is Taeyeon's balcony above the ground to the nearest meter? So let's go ahead and solve this. So we'll say this is the solution for A over here. So we need to figure out how tall Taeyeon's balcony is off the ground. And this height here is going to be the same as this height here. And now we can get to work with our trigonometry. Okay, so we know, let's label the sides of this triangle here. We know that the side opposite the 90 degrees is the hypotenuse. The side that's touching the 40 here is going to be the adjacent. So adjacent is 30. And we want to find this distance here, the opposite. Okay, and since we're looking for this one, we can call it x, or we can call it op, whatever you like. Okay, and so we're dealing with adjacents and opposite here. Okay, so we're dealing with adjacent and opposite. So let's go through SOHCAHTOA. We have SOHCAHTOA. And since we're dealing with adjacent and opposite, that's going to be tan. So we're just looking at this triangle here. So tan of 40 degrees is equal to adjacent, sorry, opposite over adjacent. So we don't know what the opposite is, that's our x, and our adjacent we know is 30 meters. Again, we can solve for what tan 40 degrees is, so let's go ahead and do that. So we're just going to pull up our calculator here, and we're looking at for tan 40 degrees. So tan 40 degrees is equal to 0.839. So this is going to be 0.839 is equal to x over 30. And to solve for what x is, we're just going to multiply 30 on each side. Okay, these are going to cancel here. So we're going to get 30 times 0.839. So let's figure out what that is. Times 30, which is equal to 25.17. Okay, so 30 times this is going to be our x, so x is equal to 25.17. Okay, so that's how tall Yuri's balcony is off the ground. So this distance here, we figured out to be 25.17, and here it says to the nearest meter, so it's 25 meters. So we know this is going to be 25 meters. Okay, so that's solution A. So let's do solution B here. How high is Yuri's balcony to the ground to the nearest meter? So Yuri lives up here. So what we're going to have to do is find this distance here using the angle of elevation. And so we're looking at this upper triangle here, and we want to find what this distance is. And we're going to have to add it to the 25 meters that we already found. So let's go ahead and do that. Okay, so we're looking at this new triangle on top here. So this is hypotenuse, the longest side opposite the 90 degrees. Adjacent is going to be the same here because it's touching the angle. So the adjacent stays the same. And the opposite of the 20 degrees is going to be here. We'll call this y. Okay, so let's solve for y. Again, we're dealing with adjacent and opposite, so we're going to use tan again. So we can jump to this. So tan 20 degrees is equal to opposite over adjacent, and its opposite is y, so y over adjacent, which is 30, and we just want to solve for what y is. So let's solve for what tan 20 degrees is. We can do that in our calculator here. Clear this. Tan 20 degrees, let's close our bracket here, is equal to 0.363. So 0.363 and is equal to y over 30. And again, to get rid of the 30, we're just going to multiply 30 on both sides. 30s are going to cancel here. So we have 30 times tan 20, or 0.363. So we're going to go back to our calculator. Since we already have that in here, we'll just multiply this by 30. And we're going to get 10.91. So y is equal to 10.91. And since it's 10.9, we're going to round that up to 11 meters. Okay, so y is equal to 11. So the distance here, let me just erase this. So the distance here is 11 meters. Okay, but the total distance from the ground to Yuri's balcony is going to be the addition of these two parts here. Okay, so let's find the total distance. So we could say distance to Yuri's balcony is equal to 11 meters plus the 25 meters that we already calculated earlier. So 11 plus 25 is equal to 36. Okay, so we can conclude Yuri's balcony is 36 meters from the ground. And we forgot to write a concluding statement here. Tayon's balcony is 25 meters from the ground. So let's fill that in here. And there we have both our solutions.